So David and Don, it's just after 6 o'clock. Shall we start?
Sure, John, let's go ahead and let's start, and because there's a lot of slides to go through, so I think it's prudent. So
Okay.
I can introduce the Oxford County team on this if you want.
Sure, go ahead.
All right, so we have in attendance tonight David Simpson, the Director of Public Works. And we have Mackenzie Schultz, who's the Wastewater Supervisor of Technical Services. And we have myself, Don Ford. I'm the Manager of Water and Wastewater Services. And I'll turn it over to John Terrell from RV Anderson.
Thank you. So welcome to the 2024 Water and Wastewater Master Plan for Oxford County. This is the second public consultation center. My name is John Terrell. I'm the project manager for RVA, who are the consultants helping the county with this project. So we had a meeting back, I believe, in September of last year where we introduced the project, and this is the second meeting, of the master plan, and basically we're presenting our preliminary results for agency and public review and comment prior to finalizing the master plan and going to council. Because this is a public meeting, it is being recorded, so I just want to bring everybody's attention to that. I think on the first slide we were reminding everybody, but the intent here is to record it in case people who weren't able to attend can attend, can listen to it on the Oxford Speak Up website. So again, if there are questions during the meetings, please use the button to raise your hand. I probably won't be able to see it, so I'm hoping somebody from Oxford County will let me know if anybody has any questions. Once I get going, I get a full head of steam, and if I don't see it, I won't stop. So please, if you have any questions during the meeting, please raise your hand. Certainly you can submit comments via email or phone. There's the you can leave a comment or question for the study team on the Speak Up Oxford site, and certainly you can you contact either myself or Don Ford, who is the lead on behalf of the county on this. Few other housekeeping items. Please, when joining online as attendees, your microphones and videos will automatically be disabled. Again, if there's a really important question, please raise your hand. Again, we'll have opportunities at the end of the presentation to ask any questions, and then obviously we can submit comments. Again, this is being recorded, so if you're listening in, hopefully you've given us consent to do that. So as Don mentioned, we have a lot of stuff to go through, so we'll try and get this wrapped up within the time allotted, so we'll just launch right into it. So the purpose of this second PCC is to allow public to understand the planning level recommendations from the draft master plan report. The recommendations have been reviewed by the internal technical advisory committee, which is county staff, and the external technical advisory committee, which comprises the county's municipalities as well as agencies. And input from these meetings has been used to develop where we are today. And obviously, if there are concerns or issues brought forth, we'll certainly review them with the county and see how they can be most appropriately addressed. So just to go back and give you some background, the goals of this water and wastewater master plan is to provide water and wastewater strategies to service existing settlement areas and growth to the year 2046. to develop water and wastewater strategies that are consistent and conform to the provincial policies, legislation, and support the county's official plan and other strategic initiatives. We're looking to identify options for optimizing the effectiveness of existing water and wastewater infrastructure, and then also to develop an integrated multi-year water and wastewater capital plan, which affords infrastructure reliability, redundancy, and sustainability. So this is usually the slide I make a joke that there will be a test at the end, but this is the current, what this flow chart is showing is the current class environmental assessment and master plan process that is in effect in the province of Ontario. And this is essentially allows municipalities and other proponents to plan municipal infrastructure in a standardized, using a standardized approach and method, so that everybody who's involved in the process has a good understanding of what's going on, and that there's certain gates that are hit by the proponents to make sure that we cover the bases. So there's up to 5 phases in the master plan or in the class environmental assessment process. The master plan typically covers the first 2 phases of this process. It's at a very high level. We're not necessarily getting down into a lot of granular detail, but the intent here is to identify the problems and opportunities that arise from what are the pressures and happening, and growth pressures and other issues happening to the infrastructure over the next 25 years, and then develop alternative solutions. Once we develop these alternative solutions and put them in the master plan, then through the class environmental assessment process, some of the projects will be things that the county can immediately implement. They no more planning required. Other projects, depending on their complexity and their schedule within the class environmental assessment process, will have to undergo an individual class environmental assessment, either through phases 1 and 2 or through phases 1 to 4. And then phase 5 is essentially the implementation phase, when infrastructure can be built and brought into service. So just as a recap, we had the first PCC back in September, so we're at the point now with PCC2, where we've identified solutions, we've reviewed schedules, we've reviewed the environment, we've looked at alternatives, and now we're sort of giving you an overview of what we're thinking in terms of the plan. And then following this, with your input and then with review by County Council, the master plan will be finalized and put out for another 30-day review for the public to give final comments. And then from there, the county will be able to use this as a roadmap for implementing the infrastructure it needs for the next 5 years. The problem opportunity statement. This is something that, again, at the beginning of an environmental assessment process or master plan, you have to say what are we trying to do, and this is what the problem opportunity statement is getting at. So, the problem opportunity statement for this wastewater master plan is to identify preferred water and wastewater servicing strategies to meet Oxford County's growth needs to 2046. As well as provide effective ongoing continuity to existing service settlement areas across Oxford County as appropriate. So, one of the main drivers, not the only driver, but one of the main drivers for, the master plan is the growth that Oxford County is anticipating to occur in the next 25 years. So, this table gives a quick snapshot of what the county, through their planning department, thinks will be the residential population growth between now and or 2021 and 2046. So in that 25-year period, we're going from about 125,000 folks to 163,000. So that's a growth of 38,000 people. So that's certainly, that's actually a good, healthy growth rate. It's not crazy, but it's very good, because with growth like this, there's a certain level of affordability for new infrastructural and renewal of old infrastructure. As well, the other aspect to the growth that we've also tracked in this master plan, and again, through figures developed with the county planning, would be the equivalent non-residential population. Sorry.
John, there's a hand raised up.
Okay.
Go ahead, Deb.
Thank you. Thank you. Can you hear me?
Yep.
Okay. So my question is, how were the population numbers determined? Like, how was this growth forecast determined?
Well, basically, again, we'll have more description of it within the master plan document, but essentially, the basis, I believe, for that was the current development, the previous development charges population growth, with a review by county planning to bring it up to date. So that's sort of where we got the we developed the numbers for it. Obviously, there's a new development charges study that will be started, so potentially the numbers will change, but the idea is to give us an idea of what the growth is. So again, the population came from, to be consistent with other initiatives. There was a transportation master plan. There's the development charges. It came through the county planning folks. Don, any other better explanation of that?
No, that's correct. It came through community planning, and they provided both the residential and the non-residential projections that are used in these tables. So that's the source of the information.
Okay, well, I guess I would just raise a concern that like everything hinges on population growth, and we've seen this in the past where the growth targets were completely blown away, and now we're creating a plan till 2046. And if these numbers, like, I'm going to say, I think they look a little low to me. If they're not accurate, we're laying out a plan that won't be accurate either.
Yeah, so the one thing to keep in mind is that the master plan process, and we'll talk about it later on, we look at future projects, it's updated every 5 years. So certainly the one thing that will happen is there's much more granularity as to, what are the projects sort of in front of the county for the next 5 to 10 years, so that if there's an issue with the population forecast, it can be addressed as well. So and certainly population growth does also allow for revenue growth as well, so that so usually there's a tie-in between the affordability of new infrastructure and the fact that you need new infrastructure for new development, whether it's residential or non-residential. So just sort of getting back to the non-residential. The non-residential, I mean, we call it non-residential. A lot of people, it includes employment growth, but again, there is a non-residential component. Again, if you talk to the planning folks, they'll probably give you a better understanding that as well. But again, significantly present or around 2021, we figured, well, there's the equivalent population of non-residential 62,000, and that's to grow to over 78. By 2046. So again, that's a significant amount of growth over the period. So the so when we're looking at the reviewing system review, when we're looking at the water and wastewater, when we're looking at, we established design criteria for the water and wastewater system. So we reviewed the current issues that some of the infrastructure would have. And that includes capacity issues, but there could be operational issues. There could be life cycle issues depending on the age of the infrastructure we're looking at. We projected out system demands for each system, the water systems and the wastewater systems. We identified issues to review, including growth, which again is one of the big ones. But there's also other risk issues and climate change issues that the systems would have to look at as well. And again, one of the other things we also looked at, particularly on the water side, is around what we call firm capacity, in that particularly on the water supply side, you really have to provide service at the maximum day that you need when your largest well or your largest pump or your largest treatment train is offline. So that's another consideration when we're looking at reviewing. With regard to finding the potential projects, we reviewed the issues and identified solutions. We identified projects and proposed timelines for the requirements. And also we try to consider solutions that could address issues across multiple systems or, multiple communities, so that, if you don't have to build two of something in two different water systems, say if they're 5 or 6 kilometers apart, if you can build one and say connect the two. So there's always safety, and the more people involved in a system, the more the better it is. There is a certain amount of safety in numbers. So when we look at the water systems, we're looking at a total of 17 systems. Each of the large urban centers, Ingersoll, Tillsonburg, and Woodstock, have their own systems. Within the rural townships, Blandford Blenheim has 4 systems, or 3 separate systems. Drumbo and Princeton are combined systems. Drumbo provides the water service to Princeton. Norwich has the Oxford South drinking water system, which ties together Norwich, Otterville, and Springford. Southwest Oxford, there are 4 standalone systems. Sweeburg is serviced by Woodstock, and East Zora, Tavistock, and Zora each have 3 systems, obviously of varying sizes. So again, I'm sure most of you know the the map of what Oxford County looks like. There are the systems are widespread. There are some very small systems. Durham Center and Lakeside are particularly small systems. And again, you have larger as well as a larger system. So it's quite an eclectic collection of systems to review on the water side. But certainly it's certainly something that we can we looked at. And there's for example, there's about 639 kilometers of distribution water mains. There are 39 reservoirs and storage towers, 6 booster pumping stations, and at this point 64 active water supply wells. So there is definitely a lot going on. When we're looking at, just to give everybody an idea of the components, we're looking at a water system. We're looking at the water supply is again well-based in Oxford County. So systems are serviced by 1 or more groundwater wells. Integral to the wells is typically a pump, but sometimes wells are tied together and then are pumped from a common well house. Water treatment can be at a one single well at a well house associated with the well, or it could be a centralized treatment facility with multiple wells. There's different types of treatment. There's obviously disinfection treatment to ensure that the water is safe in terms of the requirements from the Safe Drinking Water Act. There's also aesthetic treatment if the water is is hard or has iron in it. And then once the water is treated, it's distributed to the consumers, and that's via water mains, booster pumping stations, and in bigger centers such as Woodstock, there may be different areas that have different pressure zones just because of the variation in topography. Certainly, Tilsonburg's another area where the topography varies quite significantly, so there are multiple pressure zones. And then finally, you also have water storage, and water storage is important because in some cases, you can have enough wells, but the wells are good to get you enough flow for the day, but there are times during the day when there's a higher demand. Everybody gets up in the morning, showers, flushes the toilet, makes breakfast, then leaves, and then comes home at night. Water starts running again for dinner, for laundry, etc. So there are peaks during the day. There's also emergencies when there's fire events in those centers that have fire protection. So there is a requirement for storage, and the storage can be an in-ground storage, which is basically a reservoir in the ground with an associated pumping station, or elevated storage where the water is pumped to an elevated storage tank, and then it's distributed from there. So when we're looking at opportunities and constraints with the water supply system, certainly, water is the security supply is very important. 20 years ago, or a little more than 20 years ago, Walkerton proved that water. We tended to take water for granted until Walkerton happened, and now we really understand it has to be safe and the supply has to be secure. So to keep the water supply secure, and you have standby power to water facilities when there's a power failure, so that water can be sent into the system for people's needs. Because you have a lot of wells over time are prone to clogging and need maintenance, so there's a lot of rehabilitation that's always ongoing. Water is blended so that different characteristics of water can be blended from two different wells to make a better quality water. Other issues there too. A lot of the bigger centers are cut or bisected by the 401 or train tracks, so there's always a need for redundancy in terms of crossing, or in terms of feeder mains twinning from well supplies. If a main water supply goes down, it'll probably take a day to 2 days to find the leak, fix the leak, get the system back and running, and the reservoir is filled up. So it's a lot easier to have twinned or redundant supplies than it is, to have to deal with that. Other issues to help with water security and supply are water efficiency and conservation, and certainly in the last 20 years, there's been a lot of work on that. System redundancy is important. New well supplies are, to increase firm capacity. Again, we were looking at potentially intersystem water connections, and then within a water distribution system within a settlement or a town or a city, water main looping, so that water could come from multiple directions, because that helps to if there's a fire, or also to keep the water fresh. Certainly, when development occurs, it impacts. Because all of a sudden there is a requirement to provide additional servicing to that area. Pressure zone boundary adjustments are something that will happen from time to time. One of the province is always focused on infilling and intensification of existing lots. So if you get higher demand within existing area, that can require additional flows, and the more flows, sometimes you have to, it causes the pressure to go down, so you have to adjust that. There's new employment lands, etc. water production has its own operational issues, such as pressure. Again, we've mentioned fire flow. A lot of the water is treated to take out iron and other minerals in it through filters, and these filters basically the water from the wells goes through it. The water gets filtered. The particles get filtered, but at some point the system has to stop and it has to backwash to get it out. Similar to maybe if you're living in a, if you're living on a farm and have, say, a soft, you have soft water or something. Infrastructure limitations are something we also have to keep in mind. Everything was built, all the infrastructure at some point was built for a 20 or 25-year lifespan, and if we're reaching that, potentially we're at that span, and that goes for pumps and mains, and then the other thing too we also have to keep in account is wells. Over time, sometimes the well yield will go down. It may be an issue of the well needing to be rehabilitated, but other times there could be other long-term impacts to groundwater. Source water quality we mentioned, because it's an agricultural area, there are some wells that may have nitrates in them, iron, manganese, there's naturally occurring arsenic, in the bedrock that, again, the county treats. And another issue that all systems have is there's unaccounted water system loss, and that's loss from leakage, from connections that we don't know about, etc. So these are all the different things we have to consider when we're looking at a water system. And as far as when we evaluate solutions, there's sort of four broad categories that we look at. We look at the technical, social, cultural, environmental, and economic. So certainly on the technical side, when we're looking at if there's a noted deficiency in the water supply system, we have to address it. We certainly look at constructability. How easy is what we're planning to construct? How will it improve will what we're putting in make operations easier? It's more important to put the simplest solution in a lot of cases than the most complicated. We have to look at the infrastructure required. Depending on if we're looking at anything, we also have to maybe look out a little bit further to make sure that we've got enough land, not necessarily for 25 years, but maybe for another 25 years after that. We have to look at the approval requirements. The Ministry of Environment has approval requirements for water systems. There's also requirements depending on where the where systems are located. If they're in regulatory areas, and the conservation authorities may have input as well. Certainly, risk mitigation is an important consideration. Regulatory, supply security, and climate change. Social, cultural is another thing we have to consider. Public acceptance. Does it make sense to put a certain facility in a certain location if it's, say, within the middle of an existing residential area? There's also the impact to cultural heritage, infrastructure, and landscapes. So if the county is rehabilitating a facility that has a 100-year-old building, then a lot of times you have to take that into account when you're deciding whether it makes sense to rehabilitate within that, or maybe move to another location and then treat the heritage separately. Impact to archaeological infrastructure and resources. Usually, if we're looking at things that are off of, say, roadways or off of existing developed lots, then we always have to do an archaeological assessment to see what's beneath the ground. Environmental, obviously, impact to aquatic and terrestrial species and habitat. Impact to surface water quantity and quality if processed water can't be, say, discharged to sewers, and also the impact that climate change may have on the infrastructure. And certainly the economics, obviously a big one too. I mean, there's always the consideration of how much does this solution cost, but also you also have to look at what are the operation and maintenance costs, because over a 20 to 25-year period, the cheapest capital may not be the cheapest life cycle if there's a lot of operational maintenance costs involved in it. So those are things that have to be balanced, and they're usually looked into in the specific projects, but at least at this stage we have an idea as to what are the simpler versus the more complex things to types of solutions. Also, we certainly want to make sure that whatever infrastructure we're putting in will allow for planned community growth, so that it's not just dealing with whatever the problem is now or in the next 5 years, but again, that's why we're looking outwards to say a 25-year horizon for that as well. So when we're looking at alternative solutions, and this is common to all projects, there's sort of three or four overall concepts. Under the class environmental assessment, they always ask you to look at the do nothing option. Is do nothing a viable option? In over 20 years of doing environmental assessments, I've only ever seen the do nothing option be recommended once, but again, it's something that's that's a requirement under the Class CA, just to make sure we're covering everything. And that's generally not considered because it's not solving any, it's not addressing service capacity issues and assisting with servicing existing and planned growth. So it's we're not considering it moving forward. Limiting growth is another alternative, but that neither meets the county's vision for growth centers or mitigate risks to the existing service population. So that's certainly not being considered going forward. The alternative 3 is conservation reduction. The county does have specific programs and ongoing initiatives, and those are those are in place now, and obviously they should continue to be implemented. So that again, we're only taking the water that we actually need. And then alternative 4 will be essentially all the different concepts that we have, depending on what the issues we're looking at for the various municipalities. So so basically, we'll have various servicing concepts, which may involve new wells, new water mains, new pumps, storage, new supply and treatment, interconnection. So these are all the different. These are sort of the bag of things that we're looking at. And then when we looked at the alternatives, just to give you an idea, if there's like, let's say we have a water supply issue. So in general, these are the solutions that would be reviewed. We'd obviously looking at additional, can a well go down within the area to add to the supply, and that's a consideration. Can we interconnect the one community to another system? Is there specialized well rehabilitation that can restore or enhance the production of the wells in the area that we need more water? And certainly, again, underneath it all, the whole idea is water conservation. And again, when we looked at the different water systems, we also looked at the loss rate of each of the systems and considered if there are any that would have exceeded what would be the sort of there's sort of an industry standard, and that would be something to consider if we were looking at water supply. For water treatment, as we mentioned before, there's treatment at the well site. There's centralized treatment for multiple wells, and then also what are the treatment technologies available depending on what you're trying to treat. There's some easy ways to sort of mask, say, iron in the water, but you're not really getting rid of it. You're just sort of covering it up with another chemical, and that's not really great. So probably it's better to spend the money and go to more of a filtration technology. For water distribution and booster pumping, we can look at refurbishing or upsizing existing water mains. We can look at adding new water mains. Same with the pumping stations. We can refurbish or build new. And then the other alternative too is revise existing or create new pressure zones as required. If we need more water storage, the two general choices are you can build in-ground storage with a booster pumping station, or you can you can elect to put elevated storage in there. And then to mitigate risks, again, backup power generation is certainly something. If there's no backup power, source water protection to protect the wells if there are, activities in the area that may be impacting them, providing additional redundancy and liability, resiliency. If we identify that, with climate change, there may be, a potential that something's going to maybe impact a well site over the next 50 to 100 years. Are there means or methods to protect it? And then also understanding emergent threats, and these are things that are not localized to Oxford County, but I mean there's a lot of things that are happening in the water industry. There's a lot of research now undergoing with things like microplastics in the environment, things like that. So the county does not necessarily have to take a lead, but the county is very involved in the the American and Ontario Waterworks Association, and so they've got a good understanding of these things going forward, and certainly they can bring expertise as these issues develop. So now we're going to turn our attention to the different water systems, and just sort of give you a very high-level overview of what we're looking at. So as far as servicing capacity goes for Ingersoll, the water capacity should be adequate to 2046. The existing storage capacity will be approaching a deficit towards 2046. So that's far off, and that's a few master plans from now. So that's something that will be watched. As far as key infrastructure projects that were identified, there's the water distribution system extensions to service the Southwest Industrial Park, including and also addressing the issue of more than one 401 crossing for the water supply. There's also the Wallace Line trunk main and a South Thames trunk main as well. With regard to Tilsonburg, there's adequate storage capacity to 2046 and adequate water capacity as well. As far as infrastructure projects, there we're looking at upgrades to wells 3 and 7A. Well 3 is a well that was drilled in the 1960s. It's just off of North Street. It's not in production, but it's potentially a good well to bring into production, because there are some, there are some wells that have a lot of not operational issues, but there's a lot of maintenance required on some of the wells. So certainly the county's looking at upgrading and bringing well 3 into service to sort of assist with security. And then well 7A is on Broadway, and it's being brought into service as well, replacing well 7 in its location. Water security, again, replacement of the Mall Road wells, backup power at North Street, and then also specialized well rehabilitation to maintain well yields. We're looking at water distribution extensions to service residential employment and infill areas. Again, this involves trunk water mains, water main looping, and upsizing. Woodstock has adequate water capacity and storage capacity to 2046. Key infrastructure projects, water security, source water protection, the water tower backup power generation, the south side water treatment facility replacement. It's a lovely old building, but it's certainly something that's at the end of its lifespan. Thornton feeder main twinning. The Thornton feeder mains, the Thornton well field is south of Woodstock, between Sweetburg and Woodstock. It has most of the water supply for Woodstock, and again, there's only one water feeder main coming up crossing the 401, so that's something that's being looked at twinning. Again, specialized well rehabilitation to maintain well yields and upgrading wells 6 and 9. Water distribution systems extensions to service infill areas, as well as the Northeast Industrial Park, the Southeast Industrial Park, and Carn Road. And pressure zone expansions in zones 2 and 3, and a new zone 6 in and around Carn Road. Drumbo, the township of Blandford Blenheim, for the Drumbo Princeton drinking water system, the water supply capacity will need to be expanded by 2031. There is adequate storage capacity to 2046. So key infrastructure is a new well supply, specialized well rehabilitation, standby power to the existing well fields, and water distribution systems extensions to service infill areas. Plattsville and Bright, we're putting them together. Plattsville has adequate water and storage to 2046. Bright has adequate water supply and storage to 2046. But key infrastructure, Plattsville, we're looking at a new well supply for security of supply. The two major wells are located they're not in the they're not in the Nith River, but they're on a bridge that's sort of on either side of the Nith River. And Plattsville, we're looking at a manganese filtration upgrades. Bright also needs that as well. So I think one of the driving forces with Bright, and also for water security, is to interconnect the two systems together, because that way, instead of building two manganese treatment facilities, you build one. And again, you get more redundancy with rather than Bright trying to rely on its own system for that. Oxford South drinking water system in the township of Norwich. It has an adequate water supply to 2046 and storage to 2046. Key infrastructure upgrades. Norwich well 4. We're looking at a manganese filtration system there. A new a water supply for the system for security supply, and then again some additional storage at the well 4 water treatment facility, again to help with security of supply. Mount Elgin drinking water system. The water supply firm capacity will be in deficit approaching 2031, and there is adequate storage capacity to 2046. Key infrastructure that we're looking at is the water treatment facility optimization, to make sure we're getting the full design capacity out of the two water treatment plants in Mount Elgin, and also in the future looking at a trunk water main connection to the Ingersoll system for security of supply, and to allow for planned growth if needed. Beachville has adequate water capacity to 2046, and adequate storage capacity to 2046. However, Beachville is a small center; it only has one well, so key infrastructure projects would be a new well supply and a standpipe for security of supply. Again, within Southwest Oxford, the Brownville drinking water system, adequate water storage capacity to 2046, and water treatment capacity. key infrastructure, water quality improvements, and filtration upgrades as well for security supply. Durham Center, very small system. It has adequate water capacity to 2046 and storage capacity to 2046. And the only infrastructure would be just water main replacements as required in that community. East Aurora Tavistock, the Interkip drinking water system. Again, it is serviced by Woodstock. It has adequate water capacity to 2046 and adequate storage again to 2046. Key infrastructure projects would be water main replacements there. Tavistock, adequate water capacity to 2046. Additional storage capacity will be needed by 2028. So key infrastructure will be a new well supply treatment for additional storage, but at the well 4 site. Water and again a manganese treatment facility, and also distribution system extensions and upsizing for growth in that community. Hickson has a very small system, and there's no issues noted there other than it has one well supply, but the system is so small, if there was an issue with the well, trucked water would probably suffice in the short term to address any issues there. Within the township of Zora, the Thamesford drinking water system. It has an adequate supply to 2046, and presently it has a minor capacity deficit. So the infrastructure projects, we're looking at doing something with the reservoir to make it more efficient. Part of the reservoir is being used to provide water disinfection. Basically, with the water disinfection, you need to have water with a certain amount of chlorine in it for a certain amount of time. And if we do some enhancements to the storage, we should be able to reallocate some of that space, which will free up the storage capacity. And again, water distribution extensions to as required for servicing growth. Embro drinking water system. It has an adequate water capacity to 2046. A minor storage deficit now, so looking at new storage capacity within Embro at the water treatment facility. And Lakeside, no issues noted, other than again one well supply. So when we look at the capital implementation program over the next 25 years, you'll see this is generally what we're looking at in terms of the municipalities. Obviously we've got a pretty good idea of what's happening in the 1 to 5 years and the 6 to 10 years, and the 10 plus years. Again, that's a bit further out, but again, at this point, we're forecasting this would be the outlay. And again, we have an appendix that's attached to the that shows the projects. Just so we're not here till 11 o'clock, I'm not going to go through those with you, but certainly when the PowerPoint presentation is available online, you'll be able to, if you are interested in what the projects are, you can go through this. Again, the plan totals may not add up precisely. Again, this is still in draft, so we're still moving a few projects around here and there. So again, we are, just take a look at it and let us know what you think. But this is, these are the numbers. And again, the total looks big, but if you divide it by 25, it's probably, it's not, I won't say it's not that big, but it's, I think you have to put that in perspective too. So the next portion, we're going to turn to the wastewater systems. There are 11 wastewater systems within the county. Obviously, there's the 3 within the large urban centers, Ingersoll, Tillsonburg, and Woodstock. Blandford Blenheim has Drumbo and Plattsville. The township of Norwich just has the community of Norwich. In Southwest Oxford, Mount Elgin is the only community that has it. East Shore, Tavistock. Tavistock has its own wastewater treatment system. Interkip's sanitary servicing is provided by sending its sewage via pumping station force main to Woodstock. Zora, similar to East Zora, Tavistock. Thamesford has its own system. Embro collects and then sends its sewage to Woodstock as well. So again, systems are, that's sort of showing where the systems are. There's over 600 kilometers of sewers and force mains, 27 sewage pumping stations, 9 wastewater plants. Again, there's a lot of other complexity in there too. There's also biosolids management center at the Salford landfill or beside it. So there's quite a bit going on there. It's going to take a little bit of water here. So just to give you an idea of what we're looking at in terms of components for the wastewater treatment system facilities, I think we all understand that, when you flush a toilet or whatever, gravity sewers will take the sewage from houses to the street, and then the subdivision will send the sewers, and the subdivision will send it to larger sewers, which you call trunk sewers. And then if the wastewater plant's directly downhill, it can go all the way there, but in a lot of cases it can't. So the sewage is sent to a sanitary pump station where it's collected, and then it's pumped via force main, which is like a water main except it has sewage in it, and then it will basically go to either another part of the collection system or to the wastewater plant. A siphon, there are a few within Oxford. Basically, that's where you have a gravity sewer that's going underneath a river, and in that case, basically the siphon works like your toilet. There's the water levels higher on the upstream side, and it'll push the water and solids to the downstream side. On the wastewater treatment plant side, there's when the sewage comes in, there's all sorts of interesting things that get dropped into toilets, and a lot of them you can't really treat them through. So the headworks is used to screen the sewage of larger objects, even depending on what the type of system is upstream, maybe down to 5 millimeters or 2 millimeters of solids. Then there's a liquid treatment of the wastewater, which is primary and secondary treatment. So that's basically where we take out the solids. We take out we have bacteria eat the organic matter that's within the sewage, which if you let it go into the natural water course, it would the organic material would basically be consumed by whatever's in there, and we use up all the oxygen, and the aquatic life would die. So that's why that's the liquid train. In some plants, there's tertiary treatment where required, and that reduces nutrients such as nitrogen and phosphate in the wastewater. And then before the wastewater goes out, it's disinfected usually by ultraviolet systems, and then as part of the workings of the liquid treatment train, and even there's solids management, which is basically the bacteria that's used to eat whatever is eating it. It does grow and grow and grow, so it has to be managed and taken out. and then it has to be treated, stored and disposed of. Other aspects are wastewater treatment. There's also wet weather flows. So sometimes plants will get higher flows when there's a heavy rainfall. The water will inadvertently get into sanitary sewers. In some cases, I don't think there's many in Oxford, but in some of the older centers, there may be combined sewers where everything goes to the wastewater plant. And then there could also be plants that receive septage. Basically, when you clean out your septic tank, if you're living in the country, it goes to a wastewater plant. It may have a dedicated septage receiving station, or it may have a location, usually in the headworks of the plant where the septage is dumped into. So those are the basic components of the wastewater treatment system. So when we're looking at the opportunities and constraints similar to water, they're a bit different. Obviously, the security of conveyance and treatment, standby power to pumping stations and wastewater plants. There's also need for facility resilience due to climate change. Typically, water flows downhill, so pumping stations and wastewater plants are typically in lower areas. With climate change, there has been a rise in the level of flooding in floods or projected flooding. So again, we have to take that into account. System redundancy, treatment train flexibility, solids handling capacity at wastewater treatment plants. There's lagoons are sometimes are good where they're used because they can hold a lot of water in them. Force main twinning, again, if there's if you lose a force main, if you lose one force main and you don't have an alternate route, or it isn't twinned, then you're doing a lot of you're basically pumping into trucks and sending the sewage to the wastewater plant, which is expensive, and then additional trunk sewers for redundancy. The impacts to new areas requiring servicing. Certainly, there's a collection system expansion that can be infill and intensification, new employment lands, and then secondary units, etc. There's always concern for wastewater and pumping operational issues. I mentioned wet weather events, odor control, and then maintenance of discharge criteria. Each plant has a certificate of approval from the Ministry of the Environment and Climate Change, and that requires it to maintain discharges below a certain level for certain contaminants. So that's something that has to be done regardless of what's flowing into the plant. There's infrastructure capacity limitations. There could be changing regulations and treatment requirements due to limitations in where the capacity of receiving streams. So basically, when wastewater treatment plants treat water to a certain level, and then they send it out into a water body, and the way it's set is that the water body should be able to accept the flows from the treated wastewater, and it should be able to absorb and deal with the sewage or the treated sewage, the treated effluent. Again, that sometimes varies over time. Sometimes the receiving streams become more, the limits of what can be put in there may change over time. Again, emerging contaminants are also a potential issue. And then there's also physical capacity limits, pumping station capacities, sewer and force main capacities, and then treatment train refurbishments, etc. And then again, the collection system, inflow and infiltration. When a system is put in the ground, say today, a new sanitary system, it might be nice and tight. 20 or 30 years from now, when things have shifted around a little bit, or gaskets have come apart a little bit, there may be more water that comes into the system, etc. So these are all the different things we have to look at when we're reviewing the wastewater systems. So again, county level solutions, do nothing, not really considered, limit growth, not considered. Infiltration, inflow reduction, that the county has specific ongoing initiatives. And also through the master plan, we've also, you know, noted where there are some systems that may require additional study of this. And then again, for wastewater servicing, you know, each system was evaluated in terms of the need for new linear infrastructure, pumping, treatment expansions, etc. So again, just when we're looking at alternative solutions for wastewater collection and conveyance, reducing inflow and infiltration to sewers, that's a great long-term idea. It takes a lot of money and a lot of time to do that because you have to identify where the leakage or the inflow is, then you have to fix it. Fixing it is expensive, whether you're relining a sewer or you're digging down and replacing a sewer. So that's sort of that's a sort of a generation or two to do that way. There's refurbishing and upsizing existing sewers, putting in new sewers, refurbishing or upsizing existing pumping stations and force mains, building new pumping station and force mains. And then again, you can maybe also realign some existing sanitary sewer catchment areas to better manage flows. On the wastewater treatment side, again, you can you can reduce the inflow into the plants, but you can also there's also methods of treating it as well, separate from the or as well as the normal treatment. Optimization of existing wastewater treatment plants or components is an important concept. Typically, when you're looking to expand a plant, one of the first things the plant owner will do is to see what more they can get out of the plant without expanding it, to sort of set that as the baseline for future work. Certainly, there's refurbishing, expanding wastewater treatment plants or their components. Again, sending sewage to another wastewater plant via a sewage pumping station and force main. Interkip and Embro have done that. I think it's probably, instead of building two additional wastewater plants, they're now the flows are coming into Woodstock, where there's capacity in a larger plant that can efficiently treat it. Other aspects you can do too is you can send effluent to a different receiving stream. That's maybe getting a bit into the weeds, but instead of sending it into a local ditch by a plant, which requires a much higher level of treatment, you may be able to send it to a bigger water body where there's more, the water body has more ability to absorb the effluent. Risks, again, reducing inflow and infiltration of sewers is an important thing. Backup generation is an important concept. System redundancy and reliability, resiliency, again, low areas, higher flood lines might be something that you'd have to deal with. Understanding emergent threats, again, these are things like contaminants that are we don't understand now, but maybe 10, 20 years from now, there'll be something that will be a requirement to address. Again, the county does belong to different associations, professional and municipal associations, where they're kept abreast of these sort of things. So they're in good standing to know what these are when they become something that has to be addressed. So when we're looking at the different systems, we're just going to go through them. There's only 11 this time, or 9 actually, so a little bit faster. The Ingersoll wastewater plant should have adequate capacity to 2046. Key infrastructure projects, wastewater system extension to service the Southwest Industrial Park, including 401 crossings. Again, Wallace Line and Hamilton Road trunk sewers. As far as risk goes, probably a second trunk sewer crossing of the Thames River is something that would be a good idea.
and then upgrading the wastewater plant's headworks. Tilsonburg, the planned wastewater expansion that's ongoing now should be able to service on-hold development and future growth to sometime beyond 2041. So there may be at the very end of this cycle, there may be a requirement for a phase 2 capacity expansion. Again, a master plan or two from now will be able to tell you that with a little more certainty. Other infrastructure requirements would be sewer trunk replacements and upsizing, a climate change resiliency study for the wastewater plant and the pumping stations, Stony Creek trunk sewer rehabilitation, upgrades to the John Pound pumping station and force mains, and then extension of services to residential employment infill, trunk sewers upsizing, and upgrades to the Rouse Street sewage pumping station. Woodstock, adequate capacity to the year 2046, key infrastructure projects, trunk sewer inspection and infiltration inflow reduction, upgrades to the wastewater treatment plant headworks and Thames Valley pumping station, the Brick Pond sewer realignment. Brick Pond is an older sewer that's running across a marshy area on the south side of the city. It's probably best to realign that so that you're outside of that marshy area. Wastewater systems extensions to service infill and new secondary plans, East Woodstock, Northeast Industrial Park, Southeast Industrial Park, and Carn Road. Again, trunk sewers, pumping stations, and force mains. Drumbo, there's a planned expansion to service on-hold development, and then the key infrastructure. There's a second phase of the wastewater plant expansion that can be put into place that should be able to provide servicing up to the projections to 2046. Plattsville has adequate wastewater capacity to 2046. Infrastructure projects, optimization of the plant, biosolids removal and berm repair, and again, wastewater system expansion to service infill areas within the community. The Norwich wastewater plant, there's a planned wastewater capacity expansion to service on-hold development and future growth. Once that's implemented, that should do the community past 2046. So infrastructure projects are the capacity expansion, and again, with that, removal of biosolids to ensure the capacity can be used, and berm repair. Mount Elgin, there's a planned wastewater capacity expansion to service on-hold development. That will be the infrastructure. That'll be the phase 3 and 4 capacity expansions. And then any expansions past there would require a force main interconnection to the Ingersoll wastewater system. Tavistock, there is a planned capacity expansion to service future growth. So again, that's a key infrastructure project. Will be the capacity expansion, trunk sewer and infiltration inflow reduction, William Street pumping station expansion, and other expansions of the system and upsizing for growth. Interkip wastewater system, again, this wastewater system collects sewage and then sends it to Woodstock. There are going to be some collection system constraints by 2026. So the main infrastructure project would be upsizing or twinning the force main to Woodstock to allow for community growth. The Thansford wastewater plant, there's adequate capacity to the year 2046. Key infrastructure projects would be just upgrades to the plant to keep it running efficiently over this time. Embro, again, connecting to Woodstock. Collection system constraints by 2041. upgrades to the pumping station to allow for community growth, and again, either upsizing or twinning the force main to Woodstock to allow for community growth. So again, the wastewater capital program, again, there will be more, there's additional details that will be provided in this handout once it's placed on the website. Again, there's again, the total over 25 years, it looks big, but again, divided by 25, there's certainly a lot of work to be done in the first 5 years to address certain issues right now and impending growth. Again, and then the further out growth will be, there will be a couple master plans to better define that going forward. So those are the specific wastewater capital programs. We talked about the water one. So there are some additional projects that would help with the policies and strategies for the county to sort of make sure that it's got its eyes on the puck as far as its water and wastewater infrastructure. So fire rated. So some of the projects and strategies that have been identified include fire rated systems policy in the next 5 years, backup power prioritization policy to see which facilities, both water and wastewater, need to be prioritized in terms of backup generation, consultation for servicing upgrades policy. That'll be recurring requirement every 5 years or so. Connected system rate servicing policy every 5 years. Again, water wastewater master plans will be required over the next every 5 years to keep things up to date, and same with the development and development charges studies, the technical studies that support the development charges. So so basically what we're looking at is as far as a project schedule, county council will review that. We'll have a report on the master plan at its July 12th meeting, at which time the staff will seek approval to issue notice of completion and initiate a 45-day public and agency review period, and with the intent of filing the final master plan by September of 2023. So that's all we have. I mean, I know it's a lot, and hopefully no one's completely fallen asleep, but are there any questions or comments at this point that either I or the county staff could address? Yes.
Yeah, I have one quick question. Understanding, I think a lot of the projects you spoke about, John, are going to be on the website. Do you know the timing on when that's going to be uploaded to the website so we can look at the detailed projects?
I think I defer to Don there. Maybe he can give you a better idea.
Right, so we'll get this after it's concluded tonight. We'll get this right off to communications. I'm hopeful they could post it tomorrow or shortly thereafter. It'll include the slides with the detailed projects in the appendix, right, John?
Yeah, it's got all that. Just yeah, they're gonna follow. So either bring your reading glasses or blow it up really good.
Okay, perfect. Thank you. And the only other question I had, in some of the general descriptions in what was presented, there appears to be in Southwest Ingersoll, which are newly annexed lands. I know they're going through a secondary plan there, which is including a servicing component. And I noticed some of the projects that wastewater projects that are already part of that process are also mentioned in this one. Obviously, it would appear that there is some coordination between those two different processes right now, and the same recommendations are going to be made both for that secondary and servicing plan and the master servicing plan. Is that accurate?
Yeah, we are coordinating with the different teams that are doing these reports, so that, you know, again, they're probably going to provide a more granular detail than we are, but we understand, you know, we are putting those in the context of the overall master plan. So yeah, there'll be, yeah, we're not working in silos on that. We're working together with those other teams, and then they'll be taking them obviously a bit further and in more detail than the master plan.
Okay, perfect. Thanks, John. I appreciate answering those questions, and the presentation was informative. So.
John, I just noticed that there's a couple of comments in the chat as well.
Okay. Sure. I'll so yeah, so let's, yeah, my joke is I only have 2 screens. If I had a third screen, I'd need a 4th screen. So so maybe going back in time a little bit.
John, do you want me to read you the chat question if you like?
I think I've got them. I think there's,
Okay.
I'm just gonna go, okay. So Don, you answered Mark's question on the lagoons, right?
That's
and there's
correct.
a thumbs up, so that's been addressed.
The question was further down from Mark about Interkip.
And we're, yeah.
So the question reads, if Interkip needs expanded line to Woodstock treatment, why not discontinue new home construction Interkip to save on farmland in East Shore Tavistock? Woodstock is a residential, not Interkip. So the question to you, John, is that about where the growth goes.
Hey, John, it's David
Yeah.
Simpson here. I could certainly take that if you want,
Sure.
just for simple clarity. With that proposed recommendation, and again, this is in a bit of a latter term recommendation period. Basically, we would just be upgrading existing infrastructure, so all of the work would be within a contained right-of-way. There's no loss of farmland or additional property required. It's just simply a form of an upgrade to an existing force main that already traverses from Interkip to Woodstock. So it's a pretty straightforward undertaking. Sorry, John, I don't know if you had anything to add, but that was my take on that one.
Yeah, I mean, I guess just the overall, like, where we're basically addressing servicing where the county council has decided servicing will be. So, you know, I think that was the other part. So basically, Interkip has a certain size or area it can grow into, and basically what we're only looking at servicing those areas that have been designated. And then, but again, with regard to the overall plan, we're also looking at what the population projections, I believe, have taken into account that these are considered growth communities too. So I don't know, Mark, if that sort of answers your question as well as what David said.
Yeah, I think we can just move on, John, unless there's
Sure.
a follow-up comment.
Okay.
But
I
Thank
think
you.
those are all the chat I think those are it. So yeah, again, I don't want to keep anybody you know, from anything else, especially if you haven't had dinner yet. But again, if you have any questions, you know, Don and I can certainly answer them. And, you know, typically we don't answer them. I'll say we get our story straight before we consult between each other to make sure we're giving you the right answer. But I think if you have any questions or comment, please give it to us. I think once you see the, you know, the slide deck with the additional information at the back, that might help, you know, give you some idea. But it's a very comprehensive plan. I think you know, it's there to support, you know, support all the different planning processes that need to be in place for your community in the next 25 years, and certainly with the focus, I would say, on the first 10 years is sort of the critical focus for this. Past there, I mean, you know, we're, I won't say we're guessing, but it becomes less certain. So I'd just like to say thank you to everybody for attending. I appreciate the turnout. This is pretty good turnout. You know, any questions that you have, please get in touch with us. Thank you very much.